Good morning, everyone. We have been learning about the particulate technology, which is a first semester subject. And in the last sessions, we have learned about the size reduction, various laws of crushing process, what are different types of grinding, whether open circuit grinding or the closed circuit grinding, and the difference between the wet, what are the advantages and disadvantages of wet grinding, then the different types of equipment which crush for the coarse material, intermediate material, and the fine particles and the ultra fine particles and the cutters. And in the last sessions, we have also learned the various size reduction equipment such as the ball mill, rod mill, tube mill, the gyratory crusher, and the jaw crusher. So, in this session, we will be learning about the fluid energy mill. The fluid energy mill. So here, just have a look at the diagram here. This is oval shape, the container in which you have an annular space inside which you have an annular space. Oval shape container ಇರುತ್ತೆ ಒಳಗಡೆ ಒಂದು annular space ಇರುತ್ತೆ ಅಲ್ಲಿ most of the size reduction action takes place. So particles are being suspended in a high velocity gas stream. ಇಲ್ಲಿ the feed ನಾನು ಇಲ್ಲಿ diagram observe ಮಾಡಿ ಇಲ್ಲಿ feed is being admitted to the right side of the conical shape oval shape container. The feed is being admitted at a higher pressure through a venturi. So at the bottom ಇಲ್ಲಿ ನೋಡ್ಬೋದು ನೀವು high pressure nozzle ಇದೆ. So nozzle under at a force we are forcing any material the flow rate na increase ಮಾಡಕ್ಕೆ the nozzle na we use it. And we are forcing any material at a higher pressure. So the nozzle is being used. So here the air of the superheated steam is being used and it is passed through the nozzle to the inside of the container. To the inside of the container. At the upper loop of the container, you can see the classifier outlet. Here the classifier outlet you can see, and the outlet for the collection of the product you can see here. Outlet for the connection of the product. So this is about the construction of the fluid energy mill. ಹೆಂಗಿರುತ್ತೆ ಓವಲ್ ಶೇಪ್ ಇರುತ್ತೆ, ಒನ್ ಸೈಡ್ ಇಂದ ಫೀಡ್ ನ ಎಂಟರ್ ಮಾಡ್ತೀವಿ. ಆಮೇಲೆ ಸೈಜ್ ರಿಡಕ್ಷನ್ ಏಡ್ ಮಾಡಕ್ಕೆ ನಾವು ಏರ್ ಅಥವಾ ಹೈ ಸೂಪರ್ಹೀಟರ್ ಸ್ಟೀಮ್ ನ ಕಳಿಸ್ತೀವಿ ಥ್ರೂ ದ ಹೈ ಪ್ರೆಷರ್ nozzle. The bottom loop of the nozzle container, bottom loop of the container ನಾವು ಏನಂತ ಕರಿತೀವಿ, ರಿಡಕ್ಷನ್ ಚೇಂಬರ್ ಅಂತ ಕರಿತೀವಿ. So this is about the construction. Most of the crushing takes place between in the annular space which has been created inside the which is there inside the container. So usually the compressed air or the superheated steam will be admitted at the pressure of 7 atmospheric pressure. ಇಲ್ಲಿ ನಾವು ಏರ್ ಅಥವಾ superheated steam ನ ಅಡ್ಮಿಟ್ ಮಾಡ್ತೀವಲ್ಲ, this is of very high pressure of approximately the 7 atmospheric pressure. And the oval loop, the grinding chamber is an oval loop that we have known. This is of 25 to 200 mm in diameter ಇರುತ್ತೆ. 25 to 2 mm in diameter ಇರುತ್ತೆ diameter. And the height will be about 1.2 to 2.4 meters. The height will be 1.2 to 2.4 meters of the height. And they can process and they are capable, or the capacity of that the container can process about 6,000 kg of the material of size material for the size reduction per hour. The internal classification ಏನಿದೆ, ಇಲ್ಲಿ internal classification ಏನಿದೆ, keeps the larger particles in the mill until they are reduced in a smaller size. Keep the internal particles ಏನಿದೆ, keeps the larger particles in the mill and there will be swirl around this annular area until they have been reduced to a smaller size. Smaller size reduce ಆಗೋವರೆಗೂ ಆ ಒಂದು ಇಂಟರ್ನಲ್ ಕ್ಲಾಸಿಫಿಕೇಶನ್ ಅಲ್ಲಿ they will be swirling. So ಹೇಗೆ so this is about the construction part is concerned. ಸೊ ವರ್ಕಿಂಗ್ ಪಾರ್ಟ್ ಅಂತ ಬಂದಾಗ ಯಾವ ತರ ವರ್ಕ್ ಆಗುತ್ತೆ ಇದು. ಸೊ ಫೀಡ್ನ ದ ವೆಂಚುರಿ ಓಪನಿಂಗ್ ಅಲ್ಲಿ ಹಾಕ್ತಿವಿ ಅಟ್ ಅ ಹೈ ಪ್ರೆಷರ್. ಸೊ ಸೈಮಲ್ಟೇನಿಯಸ್ಲಿ ಏರ್ ಆರ್ ದ ಸೂಪರ್ ಹೀಟೆಡ್ ಸ್ಟೀಮ್ ವಿಚ್ ಅಬೌಟ್ 7 atmospheric pressure ಅಲ್ಲಿ ಕಳಿಸ್ತೀವಿ ಥ್ರೂ ದ ನಾಸಲ್. Okay, because of the high pressure or the compressed air or the superheated steam, the particle, the coarse particle which has to be reduced in size will rub against each other. So will rub against each other so that the reduction takes place. So will rub against each other and the reduction will takes place. Reduction will be taking place by interparticular attrition. Attrition and the rubbing against the each other. The particles either rub against each other or they rub against the walls of the confined chamber. They rub against the walls of the confined chamber because of the high pressure compressed air or the superheated steam. So the reduction main ಏನಾಗುತ್ತೆ ಬಿಕಾಸ್ ಆಫ್ ಒಂದಕ್ಕೊಂದು ಪಾರ್ಟಿಕಲ್ಲು ಒಡ್ಕೊಳ್ಳೋದ್ರಿಂದ ರಿಡಕ್ಷನ್ ಆಗುತ್ತೆ. ಆಮೇಲೆ ದ ಪಾರ್ಟಿಕಲ್ಸು ವಾಲ್ಸ್ ಏನಿದೆ ಈ ಕಂಟೈನರ್ ವಾಲ್ಸ್ಗೆ ಹೊಡೆಯೋದ್ರಿಂದ ರಿಡಕ್ಷನ್ ಆಗುತ್ತೆ. This is how the reduction will takes place. And these reduced particles and the coarse particles will be carried along upper end of the loop, where at the classifier outlet the separation will take place and the feed particles will be collected at the outlet in a bag. And the coarse particles, which are not reduced, they will be revolving unless they are reduced in required size. Full reduce ಆಗೋವರೆಗೂ coarse particle revolve ಆಗ್ತಾನೆ ಇರುತ್ತೆ. So the fines congregate at the inner wall. Congregate ಅಂದ್ರೆ ಅಲ್ಲಿ ಬಂದು inner wall ಹತ್ರ ಬಂದು ಬರುತ್ತೆ. So there we will collect the fine particles. Collection ಏನು we usually take the cyclone separator and a bag collector for the product. And as we have already know, they 6,000 kg per ton, 6,000 kg per hour reduction ಮಾಡೋಷ್ಟು ಕೆಪಾಸಿಟಿ ಈ ಒಂದು ಫ್ಲೂಯಿಡ್ ಎನರ್ಜಿ ಮಿಲ್ಗಿದೆ. and they can reduce up to 1 ton per hour of non-sticky solid particles and using water 1 to 4 kg of the steam or 6 to 9 kg of air. So reduction of 1 ton per hour of non-sticky solid particles averaging up to 10 micrometer in diameter. So using 1 to 4 kgs of the steam or 6 to 9 kgs of air. This is how the working takes place in a fluid energy mill. So what are the applications of using this fluid energy mill? So it is been as it is very, so unless it is in the as the coarse particles will revolve in an annular chamber unless all the particles are reduced in size. All the particles are reduced in size. So it is being used to grind the heat sensitive material to fine powder. So it is being used to grind heat sensitive material to fine powder. ಆಮೇಲೆ ಬೇರೆ ಫಾರ್ಮಸ್ಯೂಟಿಕಲ್ಸ್ ಅಲ್ಲಾಗಲಿ ಅಥವಾ ಬೇರೆ ಎನಿ ಇಂಡಸ್ಟ್ರೀಸ್ ಅಲ್ಲಾಗಲಿ ಇಷ್ಟೇ ಫೈನ್ ಪೌಡರ್ ಬೇಕು ಅಂತ ಒಂದು ಮೆಟೀರಿಯಲ್ ಫಾರ್ಮ್ ಆಗೋಕ್ಕೆ ಫೈನ್ ಪೌಡರ್ ಬೇಕಾಗಿರುತ್ತೆ. and the quality of the product is also becomes very important there. So so this fluid energy mill is being used preferably when strict quality control is desirable. So there we are using the fluid energy mill. So ultra fine grinding can also be achieved here. So fine powder ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ so that will be lead to the ultra fine grinding. So moderately only the hard material can be processed. ಸ್ವಲ್ಪನೇ ಹಾರ್ಡ್ ಮೆಟೀರಿಯಲ್ಸ್ನ ಮಾತ್ರ ಪ್ರೊಸೆಸ್ ಮಾಡಬಹುದು by this using the fluid energy mill. So similarly you have a attrition mill and agitated mill for the reduction of the very fine ultra fine particles. And so in order to get the reduction from a coarse particle to ultra fine particles. And the cutters definitely shape ಅಲ್ಲಿ ಕಟ್ ಮಾಡ್ಬೋದು. ಆಮೇಲೆ ರಿಕ್ವೈರ್ಡ್ shape allu cut ಮಾಡ್ಬೋದು. So for that you have a knife cutters. For size reduction for the definite shape and size, you have a knife cutters and also. So you can have an assignment as the explain the construct and explain the working of artisan mill and the agitated mill. Then explain with a neat diagram the working of knife cutters. Please do attend the write down this assignment. It like it will be helpful for you. So artisan mill and agitated mill. And for the working mechanism for thorough understanding, you can go Google into, sorry, you can search in this YouTube link for the thorough understanding of the working of fluid energy mill. I hope you have understood from this session the working mechanism of the construction and the working mechanism of the fluid energy mill. So in the exam, they might ask you the construct only the fluid energy mill ಮಾತ್ರ ಸ್ಕೆಚ್ ಮಾಡೋಕ್ಕೆ ಕೊಡ್ಬೋದು. ಆವಾಗ ನೀವು ಈ ಸ್ಕೆಚ್ನ ಬರಿಬೇಕಾಗುತ್ತೆ. ಸ್ಕೆಚ್ ನೀಟಾಗಿ ಬರೆದಷ್ಟು ಜಾಸ್ತಿ ಮಾರ್ಕ್ಸ್ ಸಿಗುತ್ತೆ. You have to sketch this the fluid energy mill properly. So the sketch only can be asked for only 5 marks. And the construction part, construction the operation part ಅಂತ ಕೇಳಿದಾಗ ಸ್ಕೆಚ್ ಬರಿಬೇಕಾಗುತ್ತೆ, ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಪಾರ್ಟು ಬರಿಬೇಕಾಗುತ್ತೆ. ಸೊ ದಟ್ ಕುಡ್ ಬಿ ಆಸ್ ಫಾರ್ 10 ಮಾರ್ಕ್ಸ್. ಆಮೇಲೆ ಅಪ್ಲಿಕೇಶನ್ಸ್ ಅಂತ ಬಂದಾಗ ದೇ ಮೈಟ್ ಆಸ್ ವಾಟ್ ವೇರ್ ದ ಫ್ಲೂಯಿಡ್ ಎನರ್ಜಿ ಅಪ್ಲಿಕೇಶನ್ಸ್ ಆಫ್ ದ ಫ್ಲೂಯಿಡ್ ಎನರ್ಜಿ ಮಿಲ್ ಅಂತ ಕೇಳಿದಾಗ ಸೊ ಯು ಕ್ಯಾನ್ ರೈಟ್ ದ ಎನಿ 5 ಅಪ್ಲಿಕೇಶನ್ ದಟ್ ಕುಡ್ ಬಿ ಆಸ್ ಫಾರ್ 5 marks. So these are the possibility of asking the questions in your exam. So practicing the diagram in this unit, the particulate technology unit, the particulate technology subject, especially in the unit 1 about the ball mill, the gyratory mill, or the tube mill, rod mill, and the roller mills is very important. The sketch, if you thoroughly know, then you can easily write the construction part and the working part of the particular size reduction equipment. So practicing the drawing also is very important in this unit, the size reduction unit. So these are the tips which can be given for the exam. So practicing the diagrams is very important. Understand if you practice the diagram, you can easily write the construction part of it. And once if you know the construction, the working part is obviously you can write very neatly in the exam. So I hope you have understood from this session. Thank you all.